Thanks everybody for joining us. We'll be getting started in just about another minute or two, just giving time for a couple people to grab their lunch and get logged in. Meanwhile, if you haven't done it already, open your browser up to frontiersctsi.org and make sure you've signed up to be a Frontiers a member. That's how we keep everybody up to date on new and upcoming events. And we actually have quite a few of them, including a nice events calendar on the website for you to take a look at. And including also links to past events in case you missed one of our prior events. Okay, it's two minutes after the hour, so let me just do a couple of quick introductions. Once again, just wanted to welcome everybody to Research and Discovery Grand Rounds. My name is Ed Ellerbeck in the Department of Population Health and in Frontier CTSI. If you haven't become a Frontier CTSI member, please log on to our website to become a member. And Ashley, you want to give us the next slide of previews of events to come? I really want to make sure everybody gets this on their calendar. Thursday, February 23rd at noon, our Research and Discovery Grand Rounds will feature our own Dr. John Spertus from the Mid-America Heart Institute, talking about one of his passions related to patient-reported outcomes in clinical care. Dr. Spertus is an internationally recognized leader in this area, not only with the Seattle Angina Questionnaire, but the more appropriate one named Kansas City Heart Failure Questionnaire. And so he'll be talking about that, but more importantly, the application to real-world clinical scenarios. So looking forward to seeing you at that event. So let me now turn the reins over to Dr. Delwyn Catley, who's co-leading our Team Science Initiative at Frontiers, CTSI, to introduce our speaker for today.
Thanks so much, Ed. And thanks for giving the team science function of the CTSI this opportunity to present on the topic of team science. As Ed said, I'm Delwyn Catley. Together with Kim Richter, I lead the team science function for our CTSI. And it is our goal to promote team science activities and education. And today we're really thrilled to be able to introduce Dr. Jeni Cross to give us a presentation on team science. And Dr. Cross is professor of sociology at Colorado State and director of the Institute for Research in the Social Sciences, where she also leads the Science of Team Science Core at the Colorado CTSI. Because of that, we recruited her to be a consultant on our program, and she also is a member of our CTSI External Advisory Board. In terms of her background, she's a community sociologist who conducts research with and for community partners to solve community problems and improve quality of life. Her research is focused on issues of public health, place attachment, behavior change, community engagement, and using social networks to create systems change. Most relevant for our topic today, she and her team have developed a series of team science competency workshops that they offer at CTSA sites across the country, and ours will be one of those coming up this spring, so stay tuned for that. Her research is published in over a dozen fields of science, and she serves as a team science expert to large international team science projects and institutes working on diverse subjects from public health to biology to machine learning to urban sustainability. So Dr. Cross, we're thrilled to have you present today. And I'll turn it over to you.
Great. It's really great to be here with you all. And just a quick second, I always have to rearrange my screens after I start the share. All right, really delighted to be here. Today I'm going to talk a little bit about what the scientific literature says about team science and give you some of my own insight. So you all probably know that teams are growing in size, and they have been growing really rapidly in the last decade. This is changing the fundamental nature of the work that we do. And for those of us who got our PhDs, I got mine at the turn of the century. Some of you probably got yours before. In this time during this century, we've seen a really big change. So our norms and practices really need to shift. Right now, a typical team-authored paper in science is much more likely to be highly cited, and the most common number of authors on papers is 6 or more. So if you're used to the idea that good papers are 1 or 2 or 3 people, that has really transformed in recent years. Thinking about interdisciplinarity in the health space and in the translational space, this article by Van Noorden about how interdisciplinarity has shifted is a really pretty interesting case study. So these are his annotations from the article. So health articles, which are in that kind of aqua, are up in the high quadrant, that they have references to outside disciplines. So that's the x-axis. And then citations from outside disciplines. So other disciplines cite health articles, and they're also citing. But then if you look down at the clinical space, clinical medicine is some of the very least interdisciplinary. So of all the scientific teams I work with, the large teams all joke about physicists and how they don't do team science. And they're the little purple dot way down in the bottom left corner. But next to all those physicists who don't know how to do team science, we have a whole bunch of clinical medicine that has historically, traditionally been much less interdisciplinary. So when we think about the translational spectrum, there is actually quite a variety. There's also kind of an annotation in the middle of the screen about nursing being kind of in the middle of the spectrum. So when we think about health, clinical, and translational research, there's really wide variation across the fields in terms of how much they currently do and historically have cited other disciplines. The NIH, as you know, has been in the last couple of decades giving out many, many more center awards. And those are through, a variety of funding mechanisms. The CTSAs are the UO1s, and that's the kind of purple line here. So you can really see the kind of transformation in what funding is looking like for team science. So if we look at the number of authors on NIH-funded research, if you look at the number of authors on publications, we see those are also increasing across all of the different types, including R, Ps, and Us. So just another kind of trend line for you to think about what's really happening. So let's talk about what they're asking for. Not just NIH, but also NSF is asking for this new science that's interdisciplinary to be transformative, to be cross-cutting, and to be impactful and catalytic. And interdisciplinary research, by its nature, really has that capacity to be transformative and catalytic of new things. So what are they kind of funding, right? So some of those awards for team science are really focused on clinical and translational research. Others are really focused on what are we doing with large data, taking advantage of the large data revolution. Some things are actually focused specifically on supporting team science. They're definitely encouraging risk-taking and helping us to think about how do we build capacity for teams. So those are the things that I've been working with, is really focusing on how do we build the capacity for teams and help people make this transition from single investigator oriented science to more complex team-based science. And I just said that team-based science has the potential to be much more impactful, but let's just look at a couple of those impacts. So 3 years after publication, those papers that are more interdisciplinary tend to be less, there's kind of lowering of the citations immediately after something is published. But 13 years after publication, that trend reverses. And those interdisciplinary publications become more impactful and more highly cited. So we see a kind of strange thing that being interdisciplinary makes it harder to get funding. It makes it harder to pass through reviews. It sometimes takes longer to get published, and its immediate response is that it's not more highly cited. But in the long term, it becomes more highly cited, but it takes a little while for people across varying fields to find those things, rather than the old way that we did science, which was kind of having science that's centered around a conversation with other people who know us, and it was easier for people to kind of pick up and find that science. Other people have found that flatter teams have greater impact. So this is about how hierarchical your team is. How much are you able to really distribute leadership across different teams and have a more networked and collaborative leadership approach than a hierarchical leadership approach. So flatter teams tend to have greater impact. And their research found really specifically that when more members of the team are integrated into leading roles, the character of research changes. So the approach that we take, the subjects that we study, and our capacity to really create innovation and advanced science also changes. So when people move from just being in supportive roles to being in contributing and leading roles, it changes the nature of our research. So this is also a big shift from hierarchical leadership styles to more collaborative leadership styles. Our own research that my PhD student, Dr. Hannah Love, who's the first author here on this paper, she and I studied several teams on the CSU campus, and we found not just that having flatter teams, and this is a network diagram that kind of shows the centrality and how much people are seeking advice and getting support from people. The larger the nodes here, the more support other people are turning to them for. And you can see the two kind of biggest nodes are women. They're both larger than any of the other blue nodes, even the blue nodes that are really close to that central red node. So one of these is a PI and the other is a project manager. And the two of them together really had a high influence on this team. And we saw this pattern over and over again, that when women are really integrated into team leadership, that also improves team impact. And it's really consistent with the findings from the study I just showed you a minute ago. So if we know that interdisciplinary teams are more impactful, and we know that collaborative leadership, spreading out leadership roles, and really integrating women in important ways changes teams, what is the kind of broad literature about what makes great teams? And this literature comes from a variety of fields. Some of it is specifically studying science, and some of it is studying research teams in other locations. Anita Woolley et al. Documented something that she and her team call the C factor, which is collective intelligence. Can we predict? Is there a measure that we can make of teams that predicts how well teams will perform? And that's not their individual intelligence or an aggregation of their talent, but the collective capacity of a team. They call the C factor. And there are three things that predict that. One of them is even turn taking, that people on the team evenly distribute participation. Now you can see, thinking about that last one, that evening out leadership roles, that this evenness is part of a flat team. So it's both in participation and in leadership. The second is social sensitivity. How much, as you interact with your team, you are able to notice and tell when someone who's maybe shy or introverted really has something to say, but they might not be jumping into the fold and interrupting other people, but really making space for that contribution. These two factors, even turn taking and social sensitivity, are mediated by another one, which is the proportion of women on a team. The reason that women and the proportion of women on a team is a mediating factor for turn taking and social sensitivity is that as a group, not as an individual, as a group, women display higher rates of social sensitivity in their social interactions, and also a personal preference for even turn taking and less hierarchical structures. So if women prefer flatter teams and they want to make space for others, and they have a better social capacity for telling when people are distraught or need support or help, then that improves the function of teams. And Anita Woolley discovered this and documented it really well in experimental studies. It's also been documented over and over again by other scientists in field-based and observational studies. This research is also backed up by Google's research on their own teams. You're probably wondering what the heck this second grade Pikachu card is here for. Google had a hypothesis when they set out to study their own teams, and they hypothesized that good teams were all about having a good hand, that every member of your team had high power, like Pikachu, right? They called it the Pikachu approach, which was that they really thought it was kind of like a deck of cards and how powerful each card in your deck was. But they discovered that that's actually really not true. The truth about teams is that high-performing teams have high levels of psychological safety. People report that their teammates are dependable. They have clarity on their roles and responsibility. And people feel like the work they're doing has meaning and impact. Now, when we work with scientific teams, this meaning and impact is kind of a natural. People pick a field to be studying, and they pick their research projects because they care about meaning and impact. So whenever I come in to work with scientific teams, they don't need help understanding the meaning and impact of their work. But what they do need help with is learning how to get role clarity, improve everybody's capacity to be a dependable teammate. Now, I'm not pointing fingers at anybody in the room, but I'm pretty confident that probably each one of you has let someone down or let a deadline slip in the last week. I'll tell you that for me, the deadline that I failed to accommodate this week was the submission of my annual faculty review for activities. It was due yesterday and it's not turned in yet. So how do we improve dependability, and how do we really help teams understand how to have great psychological safety with their team? So I just want to give you a second to think about this. Are you paying attention to psychological safety on your teams? Do you know what you personally are doing to help people feel safe on your team? And do you know how to intervene when people are not? I was just on the phone late last night with one of my big teams where one of the important scientists was showing up to meetings, not having done his homework, giving people rigorous scientific critique, which we want him to do, but doing it in a tone that made people feel really demoralized. And we had to have a talk with him about how he is showing up and contributing, because the way he's showing up right now is not helping the team's psychological safety. And it won't surprise you that it fell to women on the team to figure out how to coach him and support him and talk to him about how he can show up in ways that help the team progress and feel safe. One of my own studies, this is done with a bunch of ecologists. We looked at a giant publication that had 60 plus co-authors, and they were contributing data from all over the world. How do you get 60 people to co-author with each other? And you can see the network that has the densest ties, the most ties, is that trust network. Every member of the network has a trusting tie with at least one other person, and most of them have many ties that make them connected to the core and feel a sense of trust. And that's how we get 60 people to share their data so that we can write more impactful science. The way that happened, though, was through a really distributed leadership model, and that's the figure you can see on the right. There are 4 orange nodes with a black outlining circle. So leadership on this team was really transparent, and 3 of these 4 people are women, and they were really committed to transparency and social interaction, and they spent a lot of time cultivating relationships with people so that it was possible to do this. It started with the idea for 1 paper, and it turned into 2 or 3 because they managed to build enough trust that people were able to expand on the original idea and then work on multiple publications together. So psychological safety and trust are some of the most important things, and they require a lot of work in order for us to maintain that over time with teams. The work we've been doing is to really think about how do teams develop. We've been tracking them and watching them and noticing that teams tend to build their competencies together in a kind of order, that they start with excitement about an idea and commitment to it. They need a little bit of initial trust, but trust is something that is always building. So from each step to the other, people are building more trust. So this large team I just was consulting with last night, they have built trust with each other, but when one person comes in meetings and is starting to degrade that, right, without attending to it, that team can't keep advancing and continue to be productive. After people start building trust, then they're able to really deepen their understanding of other team members' expertise and the contributions that they can make. And then they need to build a shared vision. And here, this is a really important one. It's called a shared vision. It's not called the leader's vision that people got onboarded to. So as we think about those studies, that flatter team approaches are more impactful and more successful, a shared vision is actually a real skill that scientists need to develop, how to build a shared vision with a diverse group of people. Then after you have a shared vision, you can start working on shared language. And then after that comes role clarity and responsibilities, and even deeper trust and understanding of the unique things that people bring. So notice the Google study said we need good clarity about roles and responsibilities for success on team, but that's like step 6 here. So you can see that building complex teams is actually something that really takes time. And I think this is the most underestimated aspect of team science, is how long it really takes to form teams. Okay, my computer is freaking out, and for some reason it thinks it's not plugged in. So let me hold on. Hold on, I'm gonna text some, on my phone. I cannot believe that this is happening to me, but I will be right back. So when I gotta go run, get a power cord because my normal cord seems to be not, it seems okay now. I don't know.
Maybe a loose connection or something.
I know, I plugged it in and
We've lost Dr. Cross for just a minute, but she should be back with us. There she is.
I know.
Okay.
She's jumped devices with me before, so I know she can do this.
I'm super good at managing technology snafus. I don't know what is wrong. I have 2 different offices, and in this office, it like just suddenly stops charging. Okay, let's get this PowerPoint back and rolling. All right, so in your world, am I screen sharing?
We're good.
Okay. So I was just talking about the importance of the flatness of teams and actually how long it takes to build trust and coherence and a vision. The research on how do we build scientific teams comes from dozens of social science fields that study all these different aspects of what makes teams great. So if you're, a crazy information junkie like me, there's like a lot of places to deep dive into it. But science teams have a couple of unique things going on for them in universities. And this is true for translational teams as well as other kinds of interdisciplinary teams. Almost every scientist is working on multiple teams. They have received almost no training for teaming or how to do collaborative leadership or how to lead flat teams. And they're almost always lacking all the institutional supports that would be ideal. In industry, people are on teams, and when you build a new project, you automatically give people a project manager, but here we have to figure out how to fund that and how to find the right people for the role, and university HR gets in our way. And so that time I was saying a minute ago makes it so hard to build teams. It's really underestimated. Our organizations put up real barriers to that. So if you're feeling the pinch of that, I want you to know you're not alone. The scientific field has been studying team science competencies, and importantly, they've identified that they exist at 3 levels. There are competencies for individuals, which are some of the things we were just talking about, that an individual person's social sensitivity influences how well their team performs. But there are also competencies for teams. That even turn taking, how well a team does even turn taking, that's a team competency. That's not individual. That's how well a team performs and their ability to create norms that allow them to engage in that behavior. And then organizations. This is where right now science is the most deficit. Our academic institutions and healthcare institutions are often lacking the organizational support that we need in order to do team science effectively. The article published in 2021 by Latrocchiano et al. Identifies these different domains for team science competencies. And some of these are for individuals, and some of these are for teams. I want to talk to you a little bit about one of the important ones that is a struggle for teams, which is how do we actually create role clarity for our teams? A leader in the leadership development field, Joe Lyon, says that moving teams from chaos to clarity is one of the most vital functions of leadership. And if we don't understand how leadership helps our teams move to clarity and psychological safety, then we're kind of missing the boat. One of the first ahas I had when studying team science was that a team is not a static entity. Teams are growing and changing over time. So team membership is fundamentally dynamic. Small amount of turn on a team, and the sweet spot on that is like somewhere between 20 and 30%, can really facilitate team creativity. And new team members can and should be brought in to expand team capability. So I want to encourage you to think about a team not as a fixed and static entity, but more like a sport team roster, right? The Denver Broncos are a team that exists over time, but the Broncos roster changes season to season, and the people on the field that are actually playing in any game, it changes from game to game. So I want you to think about team science teams like sports teams, that the roster might be consistently changing. Now, here's the biggest struggle for most of us. Most of us work in jobs that require us to be a little ball of energy with 55 job duties. And I suspect that everybody on the line has been frustrated by the things that you haven't delivered this week that you were supposed to, because you have 55 arrows out. Now, a business leader wrote a book called Essentialism, and he said, hey, everybody, I want you to start saying no to more things and direct your energy to only one thing. I promise you this is going to improve your life and improve your impact and your effectiveness. And I read this and people suggested it to me, and I thought, this is just insulting. I can't possibly do this. My job doesn't let me do it. And I got kind of irritated. But then I sat with it and I really reflected, and I thought, you know what? Maybe this actually can help me. Maybe I'll try. So I really started trying and thinking about how this might impact teams. So the thinking here is your job is always going to ask you to have too many arrows. You're never going to actually get to this ideal state where you have only one project, one focus, and one effort. But can you be always striving to have fewer arrows? And which ones can you get rid of? And how can you help the members on your team get rid of the arrows out that are stressing them out? I'll tell you a quick story about one of my teams. This is my dementia team. We are working with community partners who are interested in creating a dementia-friendly community and creating a variety of opportunities for people with dementia and their caregivers to participate in community events that would potentially improve the cognitive function of people with dementia, and also create high quality opportunities for interaction to help maintain the relationship with caregivers, and also to help caregivers feel a deeper sense of support. Our project is called Be Sharp, and it takes people to the symphony, but we do a whole bunch of other things too. So this is what we looked like when we started. We had a project manager and 3 co-PIs, and then we had a whole bunch of students doing testing, because we bring a few dozen people to the symphony, and before each performance, we do these little cognitive tests with them. So we gotta have 12 students show up to every performance. So this is what our little working team looks like. But then we were so successful, people loved it. They said, hey, let's take people to the theater. Let's take people to other visual arts performances. Hey, let's create a VR experience. Hey, you know, what you guys are doing is kind of the same as what they're doing with equine therapy, but maybe we can help improve the equine therapy by partnering people and having not just people with dementia go, but have people go with their care partners in ways that might help them. Oh, and hey, what about dance and actual physical movements and the arts? So we expanded overnight from 1 project to 5, and my fantastic project coordinator from Be Sharp suddenly was doing 2 roles. She was coordinating the Be Sharp program, and she was the project manager, which you know is really head cat wrangler for now 8 faculty members. You won't be surprised that she said to me one day, hey, Jenny, I'm really frazzled and exhausted. And I said, oh, I'm kind of not surprised. Tell me about that. And what should we do about it? And she said, well, I think I should give up this role of being the coordinator. And we have this fantastic master's student who has great rapport with the participants. And she's been stepping up and doing mentoring with students. I think we should give her that role. And I thought, yeah, that's an obvious thing. We shouldn't have let you take on the new role of project manager for all of these and maintain the project coordinator role. So we helped her get rid of that burden. But we also had a faculty member who was stressed out. This was a junior faculty who was an overperformer all the time. And she was really stressed out. And I finally just asked her, I said, what do you need to get taken off your plate so that you can perform better? And she said, well, these are the things I've been not doing or not getting to that are on my list of things to do. And I said, yeah, a bunch of those things are not things you should be doing. You should not be drafting the IRB. You should be having a graduate student copy the IRB for the other programs and just applying it to yours. You can review it and submit it, but you shouldn't be starting it. And she said, oh my gosh, really? And I said, yeah, oh my gosh, really? Then I realized how many members of my team, from junior faculty members to first-year master's students, actually needed a little lesson in how to share the work. And so this is the team that really taught me about how do we manage roles and role clarity on complex teams. This team does this roles inventory at the beginning of every semester. What are you doing that stresses you out? And what ideas do you have for who could do it better? How do we shift roles and responsibilities as people are growing and maturing in their knowledge and experience of this program, of research in general, and in your own career? And my team is performing so much better now that we have built that in as a regular process on the team. So now we have one big project manager who mentors other project coordinators, and we figured out what are the clear roles that all those project coordinators need to have to support the PIs, especially PIs that are working on more than one of these aspects. So thinking a little bit more about role clarity and the types of roles, this is the biggest lesson that I've gotten from all the teams I work with across different types of spaces. I love this article that was published in 2019 about the characteristics of a translational scientist. There are so many more roles that people might play on our teams, and we really weren't taught about them. In our PhD programs, you see here highlighted that we were taught about how to be rigorous researchers, and we were taught how to be domain experts. But good translational teams also need systems thinkers, skilled communicators, team players, boundary crossers, and process innovators. Not everybody is good at those. And having a good team science team doesn't mean that now we need everybody to do 7 things instead of 2. It means that we need to think about how our team can take on these different roles and how we support people in doing them. So here's a little coding scheme. I just took those same things from the article and we coded one of our teams and we looked at what are people doing on a team. And we discovered some kind of interesting things. Here's what that team looked like in 2017. You can see this kind of central team member. Their primary role is the circle on the outside. Their secondary role is the color on the inside. And so some people have multiple secondary roles. So this person's primary role is team player. They are one of the co-PIs on this project, so not a surprise there. But they also are being a boundary crosser, a skilled communicator, and a systems thinker. This is a big interdisciplinary team. Not too surprised that one of the main PIs needs to be doing those functions. But when we looked at the data on this team from 2017 versus 2020, we saw something else happening. We saw that now as this team grew, we needed those boundary crossing, systems thinking, communication skills to expand, and they did. Now we have a group of 5 co-PIs in the middle. The interesting thing about that group in the middle is that they represent 5 different career stage levels. We've got a brand new postdoc in there, and we've got faculty who are near retirement. So different people want to do that, but we also noticed that we have a bunch of people on this team on the periphery that really say, hey, I just want to lend my modeling skills to this project. And I don't want to have to think too hard or come to too many meetings, but I really want to do this one thing. So we learned about all 7 of these roles and how important it is to realize that there is room in large scientific teams for people to do only one of these 7, to do 2 of them, or to be those system thinking boundary crossers, to be doing 3 or 4 or 5 of them. The most important thing, thinking back on the data that we have on what makes successful teams, is having more flat teams. So this team's got a group of leaders that are tightly clustered together that are 5, and you can see they all look kind of different just on these roles. They also are pretty different in their disciplines. So they had to learn how to work and lead together. And we also had to learn how to talk about transdisciplinary science that values people that are doing really only 1 or 2 of these roles versus the people that are doing the boundary crossing roles. So how do we help teams work on, these kind of team adaptive behaviors and deal with complexity? This is some of my favorite science. It's the science of creativity. People who are able to engage in analogous reasoning create more creative solutions. So analogous reasoning is taking ideas from one field and applying them to another. So the human brain is super good at this. It sees human faces and faces of animals in everything, in tile patterns, in carpet weaves, in clouds, and in cars. But we also do it in science. The structure of the atom is analogous to the structure of the solar system. So 2 really different levels of scale, but really similar things. So how do we really help teams use that capacity for human creativity? And we find that a ton of research on innovation and creativity in teams focuses on diversity. What diversity brings are different perspectives, that everybody looks at the same object. In this case, it's that little blue figure on the ground. And some people see an 8, some people see an infinity sign, some people see other kinds of structures. So when you bring diverse people together, they bring their own knowledge and experience and perspective, and that helps us to maintain creativity. A publication from over a decade ago, really looked at team science in the translational space, and this is their version of that figure, that a diverse team brings more ideas in that turn into the selection of new things, and their impact is also greater because they don't just come in with more ideas and select new things. They also are able to expand that out into the community through their networks in more diverse ways. So the networks of people outside also expand that capacity for translational science. So I already talked about the importance of flat teams. And I talked about a little bit of kind of, network and thinking science. So the way that interdisciplinary advances science is through this analogous reasoning, what the folks in this article call connective thinking, which is thinking about, oh, you talked about this, and oh, I have an idea there. So I was on a team that was working on biocompatible polymers. And the group got together because their mission was to try to design polymers that were compatible with biology, compatible with the human body. And as soon as they started talking about that, they said, well, if it's compatible with life, it should also be compatible with the environment, which is that as we build them, we think about the whole life cycle of these materials, that they will not become pollutants. And then one of the chemists spoke up and he said, hey, I don't know if you guys were thinking about going this way at all or not, but one of the things that I do is think about the surface of materials and how that surface is either philic or phobic, attracting things or dispelling things. We've been thinking about it being compatible with blood, but maybe we also want to think about how materials might, in the end of their life cycle, be attractive to other things like pollutants. So it's conceptually possible that we could actually go beyond not putting bad stuff into the environment. We also could be designing materials that collect and attract the bad things in the environment. So that's an example of connective thinking or analogous reasoning that scientists do. And that's how and where innovation comes from. So you can see in this diagram shows what connective thinking looks like, how important it is to have a flat team. All of these different team members need to feel like they have the space to talk, that they're respected and honored, and that their voice actually has the opportunity to influence the direction that the team is going in. And this is why collaborative leadership is the direction that transdisciplinary teams need to go. Now, unfortunately, we have to fight a little bit of human psychology. Human beings prefer convergent thinking, which is coming into a room and talking with other people about all the things that you know together. People do it to protect their own ego, to demonstrate that they're smart. And so people talk about the stuff they know together, which is convergent thinking. That's our human comfort zone. But innovation comes from actually divergence. It comes from that picture of all those people with different perspectives sharing their take on what is the direction that we could go. So if the best science begins with harvesting and listening to and making space for all those divergent ideas, we've got to have processes that help us engage in divergence more than convergence, because our natural tendency is to work on convergence. The folks in communication studies really study this deeply and broadly. Kaner has written a book on deliberative decision-making in teams, and he talks about this cycle of divergent to convergent thinking. Now, remember I said earlier, one of the things we don't give teams enough time for is time to form. We also don't give teams enough time to think together. If you start with a new topic, then the next thing that happens is you start thinking about, oh, what are the familiar and known ideas? But we really want to get to that space where we're really thinking about those diverse perspectives, and that's the peak of the divergent thinking. Almost always, in a process, people truncate stuff because they say, we need to take action, we need to get to action. So people want to make it happen too short, and they want to skip over the middle, the convergent space. Kaner calls this the groan zone. And this is one of the first things that we can teach teams, is that you need to give yourselves more time in the groan zone, contemplating ideas and possibilities, and making space for everyone to share their ideas and perspectives, and even the things that look like they might hang up the team, thinking about what's a solution to that otherwise looks like a barrier, might help you really find something innovative in the middle of the groan zone. The way we get through the groan zone is many ways. Sometimes if you're having a big strategic planning session, you want to have that facilitated by a third-party person. So the list here that you see, this is not my personal recommendations. Every one of these is based in science. Third-party facilitators improve the function of teams. Having ground rules, how we're going to talk to and engage with each other. Spending time in active listening. Having ground rules that really focus on even participation. And my favorite one is having fun. Fun is shown to improve the performance of teams. And engaging in those connective thinking that previous slide talked about. This takes time and it takes space. And it's one of the things that in academic settings we often have the least of to work with for our teams, but it's what we really need to be working on those translational topics and finding innovative solutions. So I think I want to just end there. When we talk to scientists and qualitative sociologists and anthropologists have studied this and they've said, hey, why do you engage in these large teams, these teams that are hard, these complicated teams? Why do you do it? And this is why. People say, I do it because it's fun, because it increases my productivity, because it gives me more opportunity for creativity, because I enjoy the opportunities for mentoring, and because it helps me be more impactful in my science. So this is why we do it, even though it's hard, even though our institutions are often putting up more barriers than they are providing solutions. So I'll end there and hopefully give us a couple minutes for questions.
Wonderful. Thank you so much, Jeni. That was really, really interesting and fun. I had a hard time keeping up with notes I was taking. So I kind of liked it when you had a technological
People
glitch.
always want them.
Just while Delwyn's getting his questions together, yes, Ashley just laid it out. Please put your questions in the Q&A or in the chat for us, and Dr. Catley and I can moderate those. So turn it back to you, Delwyn.
Okay. Well, so we already have a question in the chat, so let's go ahead and answer that, and I'll save my question if there's space. You may cover this, but how do you develop the shared vision you spoke of is the question from Julius Leary.
Really, the best way for developing a shared vision is having a carefully moderated conversation with the team. Unless you're brilliant at this, and most people, this is a skill that we have to develop, is how to really facilitate a team through that divergent and convergent thinking about what are all the possibilities, what are the connections between spaces, and there are lots and lots of really fun activities that people in the social sciences have developed for both strategic thinking and also for creative thinking. So there are whole consulting companies that do nothing but this, and they use the processes from creativity studies to help teams get at that. But to begin with, if you're a team leader, it requires kind of making space and time for that group conversation and then having it well facilitated.
Okay, great. At the moment, I don't see another question, so let me ask mine. Could you talk a little bit more about those specific team roles? Like, you know, a couple of them are obvious, but the boundary crosser and the systems thinker, et cetera, et cetera. There were lots of interesting ones there.
Yeah. I'll give you a quick example. Working with one translational team, and I asked them about those arrows out. I asked every member of their team to write down, if you could only contribute one thing, your arrow up to your team, what would it be? And then I asked everybody to write on Post-its, what are the things that are keeping you up at night? And we put all those Post-its on a board. And a bunch of them were coordinating tasks. Not a surprise, academic institutions are really bad about giving people the administrative and coordinating support they need. But there were a whole bunch on this team that looked to me like just doing science, like processing samples or data management or something. And I couldn't figure out what the problem was. So I pulled all those little Post-its together and I put them in a little area and I read them all off to the team. And I said, those of you who wrote these, I need you to talk to me about why this stuff that to me just looks like the daily life of doing science, why is that stressing you out and keeping you up at night? And I had 2 junior faculty and a postdoc weigh in. And what we discovered was that the faculty members were spending way too much time on daily task stuff in the lab, because the lab work in this case was kind of boundary crossing science. It was bringing together information and knowledge from different fields. And they didn't have anybody in their lab. They didn't have a grad student or postdoc who could do it. So faculty were spending more and more of their time every day managing it. And 3 of them were doing it. And so as we talked, what we realized is that that team was missing someone with deep scientific knowledge and the capacity to span the boundaries between those labs. Our normal way of science is kind of hierarchical, a PI, and then their postdocs, and then their grad students. But the work that needed to happen actually was work that needed to link those 3 labs to each other. What they really needed was a boundary spanning postdoc who could spend time every week in the 3 labs, mentoring grad students and talking to the PIs and figuring out the complex coordination between them. So it was a real scientific boundary spanning activity.
Cool. Okay, well, I could ask you more about those other roles too, but we already have more questions. So let's move on to those. What are some beginning resources for learning to develop effective teams? And also, what is your favorite book on leadership? That's from Tanisha Sharman.
Okay. So I would say, I'm not sure it's beginning resources, but it might be. There is a giant book published in 2019 called Strategies for Team Science Success. And Carol Hall is one of the editors on it. You can find it online and you can print out any of the PDF chapters. It's probably like 50 chapters.
Because of you, we've purchased that book. And so it is now available to anybody who would like access to it.
Yeah. So I think it's kind of like the big reference manual. So I'd say that. A guy named Rob Cross, no relationship to me, studies social networks in organizations. And he has written a book on collaborative overload. So I think that his book is more helpful than the Essentialism book because he actually is an organizational scholar and has looked at what are the ineffective patterns that leaders are doing that are keeping them in that loop of collaborative overload. So collaborative overload is something that most of us are facing. And we can either be making it worse, or we can find some strategies for making it better. So Rob Cross has a book on collaborative overload, which is, I think, maybe one of the more helpful ones on leadership. And then curious about cultivating fun. Yes, cultivating fun takes time, but it doesn't have to be a time suck. So a couple of things are get your super business-oriented linear people on your team to realize that building social connections is as important to good science as getting down to work. And that means letting the first 10 or 15 minutes of a meeting include social connection. Having space for team check-ins is part of the time and space that we need. We also are almost all Zooming from one meeting to another. So we're all really struggling with that transition time. So if you plan for the first 10 minutes of your meeting to be social connecting and checking in, you're helping everyone reduce that cognitive load of that burnout from back-to-back meetings. And you're doing double duty with building that social thing. So the other thing about fun is for your team to figure out like what fun is, right? So fun is sometimes like silly little, goofy things that are part of team culture. Sometimes it's deciding to have lab meetings at the brewery instead of in the lab. So if you say what can help us, have more fun together and have time for fun, talk to your teams. And there's usually someone who's a natural social coordinator and will rise to the occasion and have more ideas. If you're the one who struggles with this, I guarantee that you have young members of your lab who are just dying to be asked to become the social coordinator and have that be valued.
Yes, I can confirm that is true.
I wondered if you could comment on unique challenges faced by a junior investigator. So imagine a K awardee who may have never supervised staff before. She's got her first GRA. And yet she's also bringing in mentors onto her team where there's a power differential here. What are some of the challenges or lessons, and maybe getting back to Tanisha's questions, what resources or guidance do you actually provide for them?
That's a great question. Most of that guidance we're doing as kind of individualized coaching that we do a bunch of coaching with PIs and teams. The one kind of commentary I would make on that is that med schools tend to be the environment where this hierarchical assumption about how you get promoted and how you advance is the strongest and most frustrating. So I think you've really identified a real kind of conflict point, that we have a lot of junior scholars who do not want to be doing science in that hierarchical kind of framework, but they're being mentored by people who are a generation or two older than them, who still think that's the only way. So what we have found is that team science training workshops that we're doing on our campus helps to build a cohort of junior scientists that all have kind of the same knowledge. They still complain and they're like, and when are you going to shift our leaders and our mentors to this? But they find it really valuable and helpful to build a cohort of people that are learning the same things and building their kind of collaborative leadership skills together.
So you're saying mentors aren't necessary and they just get in the way, or how do we?
I'm saying that the old dogs who don't know what collaborative leadership are sometimes the source of trouble for our junior faculty, and that they need to up their game, and maybe they need some collaborative leadership training in order to be better mentors.
Okay. Well, Ed, should we wrap it up now, or let's see, we've got 3 minutes. So
yeah, we got one last question, I think, from Ashley. How can institutional leaders and facilitators help our busy PIs prioritize skill building in those soft skills like communications, emotional intelligence?
That's a great question. The fastest and easiest way that I've found to help PIs prioritize it is to bake it into their funding mechanism. So if you have grant awards and seed awards that help people build new teams, you build that professional development into the expectations for getting that seed award. Our own experience on many campuses is that once we start offering team science to people and they attend the first one, it increases their appetite for more. But you've got to find a space when people can actually do it. The more senior people are, the less room they have in their lives and their schedules for this. So you have to figure out how to build those opportunities and professional development times into the work that they're already doing. Because when it's one more thing, nobody has time for it, even if they find it super valuable. But my most senior PIs, once they go through the first thing, they say, oh my gosh, this is so valuable, and I wish I had it earlier.
Fantastic. Can I just say one quick thing? I know we're about to end, but we are wrapping up a survey on needs and interests in team science at Frontiers. So if you haven't filled out our survey, please, this is your last chance. It is posted in the chat. You can just click on the link, and it's a real quick survey, and it'll be super helpful for getting input on how we can best help everybody here at Frontiers. So I think with that, Ed, it's probably time to wrap up and say thanks a million again to Jeni for your wonderful presentation. And we definitely look forward to working more with you on developing some of these trainings and resources here at Frontiers.
We'll be following up on some of these questions and issues when you come out here to visit us in March. Looking forward to that.
Yeah, looking forward to it too. And I will prepare a PDF of these slides and send them off to you, Delwyn, and then you can share them with everybody else.
That would be awesome. Thank you so much.
Yeah.
And thanks everybody for joining us today for Research and Discovery Grand Rounds. Okay, stay tuned for future events. Thanks.
Thank you, everybody. Bye-bye.
Bye.